Chapter number 5, derivation, and this is the class 12 subject mathematics. I am telling you about the derivation. So here is a question: fx is equal to modulus x minus 1, where x belongs to R. For derivations, for prove that this is differentiable at x is equal to 1. So for this we are considering as this left hand derivation is equal to right hand derivation. We have to require both the derivations, left hand derivation as well as right hand derivation. If the left hand derivation and right hand derivation both are equal, then the function is differentiable. First of all, we define the function. Here is a modulus x minus 1. So x minus 1 is equal to 0, x is equal to 1. So discuss the nature of the this function at x is equal to 1. If x is less than 1, it means less than 1 means 0. You put down here 0, 0 minus 1. This is inside, the value is negative. So we are taking x minus 1 negative. If we put x is greater than equal to 1, then x minus 1 is positive. If you put here 1, 1 minus 1, 0, and 0 is always positive. So function is defined in this manner: fx is equal to minus x minus 1 if x is less than 1, and x minus 1 if x is greater than 1. So now for the differentiable, check the differentiable. We are taking left hand derivation and right hand derivation. The formula of the left hand derivation is equal to left hand derivation limit h tending to 0 f x minus h minus fx upon x minus h minus x. This is the formula for the left hand derivation. Here is x is less than 1. We have to check here x is equal to 1. So x is replacing by 1. So the formula for the left hand derivation f1 minus h. So already we have taken f1 minus h minus f1. Here is x is equal to 1, 1 minus h minus 1, 1 minus h minus 1. So limit h tending to 0. So f1 minus h for the left hand derivation discuss. Here left hand derivation is discussed. So we are taking x is replacing by 1 minus h. Here in this position x is replacing by 1 minus h. Negative sign is here, and this x is replacing by 1 minus h minus 1. This is the value of f1 minus h. f1 means this is the equal sign is here. So 1 minus 1, this is 0. You can replace here also f1 is equal to 1 minus 1. This is 0. And the denominator 1 and minus 1, this is cancel. We get minus 1. So this is also cancel. 1 and minus 1 cancel. Minus minus plus. So h upon minus 1, we get minus 1. Same as the right hand derivation. Right hand derivation we are taking as a left hand derivation x minus h, and right hand derivation x plus h minus fx upon x plus h minus x. Replacing here x plus h minus x, here also x plus h minus x, and x is replacing by 1. So right hand derivation f1 plus h. This is 1 plus h minus f1 upon 1 plus h minus 1. This is the formula. For the right hand derivation, here we discuss as the right hand derivation. Here is x is replacing by 1 plus h. In this position, x is replacing by 1 plus h minus 1. So we get f1 plus h is equal to function of 1 plus h is equal to, here you replace 1 plus h minus 1. We get 1 plus h minus 1. And f1 is equal to, replacing f1 is equal to 1 minus 1, 0. Either equal sign is here, also 1 minus 1, 0. So f1 is equal to 0. And denominator 1 minus 1 is cancelled, we get h. So this is also cancel. Minus 1 plus 1 cancel. Limit is tending to 0. This is h upon h, 1. So left hand derivation and right hand derivation are not equal. So function is not differentiable. So this way we can check this method, the function is differentiable or not differentiable. Now I am telling you how you differentiate inverse questions. For example, y is equal to 10 inverse x is given. So how can we differentiate this function? So first of all, 10 inverse transpose in this side, we get 10y is equal to x. Now differentiate with respect to x. So derivation of 10y, this is the sec square y, and the y derivation with respect to x, this is dy upon dx, and x derivation x is equal to 1. So dy upon dx is equal to, this is sec square y transpose in this side, we get 1 upon sec square y, and the formula of the sec square y is already, we know that 1 plus 10 square x is equal to, 10 square x is equal to, this is sec square x. So sec square y is replacing by 1 plus 10 square y, 1 plus 10 square y. So look at this, is 10y is equal to x, 10y this is equal to x, and 10y is replacing by x. So answer is equal to dy upon dx is equal to 1 upon 1 plus x square. This is, we can, inverse function is this is the complete process to the finding the dy upon dx for the inverse function. Now the question I'm telling you, as it is, y is equal to tan inverse x, already we have find the dy upon dx is equal to 1 plus x square. Same process in this, one more question also taking y is equal to cos inverse 1 minus x square upon 1 plus x square. Now in this question, first of all, let x is equal to tan theta. Here is replacing by x is equal to tan theta, so we get answer y is equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta. Now in this condition is not given. If the condition is given, then we follow the condition, but the condition is not given, direct question is given, so we put x is equal to tan theta. Otherwise we check the nature of tan theta, it is positive or negative. In this situation we know that this is the formula, 1 minus tan square upon 1 plus tan square is equal to, this is the formula of cos 2 theta upon 1 plus tan square is equal to cos 3. So already we have studied in the class 11th. So this is cos 2 theta, cos inverse and cos is cancelled, so we get, here is a 2 theta. Cos inverse and cos inverse not cancelling, remove to each other values, so this is y is equal to 2 theta. Now we get theta, from here we get the theta, x is equal to tan theta, and tan is transposed in this side, so we get tan inverse x is equal to theta. So here by replacing the theta is equal to tan inverse x, we get 2 tan inverse x. And now after simplify this question, now we write down here, differentiate with respect to x. Differentiate with respect to x means a y derivation with respect to x, we get dy upon dx. Y derivation with respect to x, we get dy upon dx. 2 constant is same, and the derivation of tan inverse already we have to proved here, 1 upon 1 plus x square, replace here 1 upon 1 plus x square. 2 constant is same, tan inverse derivation 1 upon 1 plus x square, again angle is x, x derivation with respect to x, this is 1, write down here 1, and this is the complete derivation, so we get answer is equal to 2 upon 1 plus x square, this is the answer. So one more question also. So this is the question, y is equal to log, this is the question, y is equal to log 1 minus cos x upon 1 plus cos x. For this differentiate with respect to x for the derivation, this is also question for the derivation. So first of all solve this cos x, first simplify the question, y is equal to log is same, and the root 1 minus, here is the put the value of the is cos x is equal to, we are putting here the value, formula of the cos x is, we know that 1 minus 2 sin square x by 2. In the 11th class study about this formula, cos x is equal to 1 minus 2 sin square x, and in denominator place 1 plus cos x is equal to 2 cos square x by 2 minus 1. Both the places the different formula, here is a negative sign, so we are taking the formula of sine, and the denominator place cos x is, before cos x the sign is positive, so we apply this formula 2 cos square x by 2. For this is the only for the cancelling of 1, 2 log inside the root, this is 1 minus 1 minus minus plus 2 sin square x by 2. And in the denominator place 1 plus 2 cos square x by 2 minus 1. For this process 1 and 1 is cancelled, 1 and 1 is cancelled, numerator and denominator both the places we cancel 1. So we get y is equal to log 2 and 2 also cancel, we get square, sin square by cos square, tan square, and outside the root we get tan x by 2. Now simplify the question, and now we have to write down here differentiate with respect to x. The y differentiate with respect to x, we get dy upon dx, and the derivation of log, we know that d upon dx log x is equal to, everyone you know that in the previous video log x is equal to, already I have mentioned here 1 upon x. So differentiate with respect to a dy log, derivation of log, this is 1 upon x, 1 upon tan x by 2, and then after log derivation we go to the tan. Derivation of tan is this is sec square x by 2, and then angle x by 2 is equal to half. This is the derivation of log tan x by 2. So dy upon dx is equal to the same. The tan is formula sine by cos. This is 1 by tan. This is the cot, and the cot is formula is cos x by 2 by sine x by 2. 1 by tan x by 2 means this is the cot x by 2, the cos x by 2, and the sec square is the formula is equal to 1 upon cos square x by 2 into 1 by 2. Square and this is cancel. Here in denominator place, this is the formula 2 sin theta cos theta is equal to sin 2 theta. So this is 1 upon this is sin x. Angle is double. Angle is x by 2. So angle double. This is sin x. The formula is sin x. This is the formula of sin 2 theta is equal to 2 sin theta cos theta, 2 sin theta cos theta, and sin theta formula is equal to 2 sin theta by 2 cos theta by 2. So 2 sin theta by 2, here is a 2 sin x by 2 cos x by 2 sin x, 1 upon sin x, this is equal to cosec x. This is the answer of question number 3.